And this is Algebra lesson 8.3a. Okay, the quadratic equations. Okay, here we go. I'm going to show you this. First of all, this lesson is simply each question in this lesson is a little puzzle. That's all. Each lesson's a puzzle. How many of you have ever done some sort of like a Sudoku? Sudoku is how you say it? Sudoku, right? Yeah. How do you do a Sudoku? You're kind of like, you look at this and you go, okay, if I put a 4 here, then I need a 5 here, but I can't put a 5 there because there's already a 5 in that column, right? So you know what I'm saying? Like you're just doing these weird little puzzles, right? Like in your head, you're like, what do I do? Is this what goes? Is this, That's all this is going to be really. It's just now a matter of understanding the rules. It's understanding the rules and being able to do them. So I'll show you. Here's the deal. Here's the deal. The quadratic equation looks like this. X squared plus bx plus c equals 0. That is a quadratic equation. Okay? That's a quadratic equation. This thing, do you remember what it's called? What is the thing called that goes in front of the first term? Do you remember what that thing's called? This right here, what I'm going to show you how to solve this, only works if the leading coefficient is 1. The leading coefficient here is 1, right? There's a 1 in front of there. If there was a 2 or a 3, then what I'm going to show you doesn't work. The only way, the process by which I'm going to show you how to solve this is when the leading coefficient is 1. There's other ways of solving this when the leading coefficient isn't 1, but for right now, I'm going to show you how to do this when the leading coefficient is just 1. In other words, it starts out with x squared. Now, could it start out with b squared? Sure. Could it start with, anything can be replaced for x, but almost always we write down x is right here, and it is, when the leading coefficient's 1, that's what we're about to do, what I'm going to show you. Here's the deal. Here's the way this works. Okay, let me give you one. I'm going to show you one. Here we go. This is just called the quadratic equation. All right, here we go. What if I gave you this? X squared plus 9x plus 20. Okay, I'm going to ask you to factor that. Okay, so I'm going to erase this for now. I just want you to understand, I want you to factor this baby. Now, the first thing you do, anytime you do whenever I say factor, is you look for what? See if there's something I can pull out. I'm telling you, you're going to forget to do this. And don't. You look for something to pull out. Is there anything I can pull out of all three of those terms? Is there any number or variable I can pull out? No. Only one, which means you don't pull it out, right? It wouldn't change anything. When I tell you to factor this, the first thing you look for is there something I can pull out? In this situation, there is not. Nothing I can pull out. Okay, that's fine. Here's the deal. Do you remember when I would give you something like this? X plus 2 times x plus 5. Let's look at this. How do we put that back? How do we FOIL it, right? X times x is? X squared. X times 5 is? Plus 5x. 2 times x is plus 2x. And then 2 times 5 is plus 10, right? And then you combine those two. It actually ends up looking like x squared plus 7x plus 10. Do you see what I'm talking about? Do you see that? What does that thing look very similar to? The one I gave you. Do you agree? So when I say to factor this baby, you know what? We're going to pull out what we can. We're going to make it smaller. It's going to be something like this. It's going to be two binomials multiplied by each other. Does that make sense? So let me rewrite it. We're going to go x squared plus 9x plus, what was it? 20. Here's the deal. Okay, you ready for this? Here's the deal. We know that this right here, if it is factorable, if this thing can be factored, it's going to look like this. It's going to be two binomials multiplying each other. Do you know, listen, we already know that that first thing is going to be what? What's going to go here and here? X. Does that make sense? Because we know the first thing we're going to do is go x times x is x squared. So we're kind of undoing this. Does that make sense? So this is x and this is x, right? We also know that this last thing is going to be this number times this number. We know that. Does that make sense? Now here's the deal. Are there more than one choice to multiply two numbers to make 20? Are there more than one choice? There are more than one choice. So what we have to do is we have to write out the factors of 20. Let's literally write out the factors of 20. The factors of 20 are what? 1 and 20. What else? 2 and 10. And 4 and 5. So here's the deal. These two numbers are either going to be 1 and 20, 2 and 10, or 4 and 5, because those are the only two numbers that multiply together to make 20. Does that make sense? So those are our options. At this point, though, we have to go, okay, so we know it's one of those choices. What happens here? It's the two numbers added together. So when we do this, what's going to go here and here are the two factors that multiply to 20, but that also add to 9. Two numbers that multiply to 20 and add to 9. Well, which ones are that? Which ones are 1 and 20, 2 and 10, or 4 and 5? 4 and 5. They both need to be positive because that's positive, and when we add them together, plus 5 plus 4 is plus 9. So there it is. How do we know if we got it right? Foil it, right? What is x times x? X squared. What is x times 5? 5x. What is 4 times 5? Plus 4x. What is 5x plus 4x? 9x. And then what is 4 times 5? 20. Does that make sense? Okay. Let me give you another one. Well, you guys try this. We'll just give you one that's easy. A d squared plus 11x plus 24. Try it. I made a mistake in drawing that. That needs to be a d. They need to both be d's. Attention. I want all eyes up here now. All eyes up here. For real. Pencils down. Eyes are up here now. Pencils down. I want your eyes up here. You need to understand the process. This is not difficult. Once you understand the process, you're like, oh, okay, that's so easy. Right? I go through all of this because on your test, the instructions are just going to say factor. And so I go through each one of these little steps, even though right now you know you don't need to do that. On your test, you won't know which ones you have to pull something out. So then I go through the process. On your test, I'll say to factor that. First thing you do whenever you see factor is, what can I pull out? What can I pull out of there? Okay, can I pull something out of here? No, I can't. Okay, that's fine. This is a, what is this called again? It's called a trinomial. What very specific type of, it's called a quadratic. This is a quadratic. Okay, in a quadratic, when you're going to factor it, if you're going to be able to factor it, what's it going to look like? Two binomials multiplying each other, right? It's going to look like two binomials. Remember, the first two letters, the first two terms are going to multiply to that. The last two terms are going to multiply to that. And the middle two terms are going to add to this. Does that make sense? They're actually going to add to this. So, knowing that, if they both multiply to d squared, what do these guys have to be? D and D. Right? D and D. We know that. We also know that these two are going to multiply to this, but add to this. I know that some of these are so easy that you can just do them in your head, but sometimes they're not. So what is the process by what you need to do now? You need to list all the factors of 24, right? So we're going to list the factors of 24. 1 and 24, 2 and 12, 3 and 8, 4 and 6. Do you see how there's a bunch of them? Right? So, okay. Now, what I do here is I do the rainbows, right? I group them. I know what some people do is they list them. They'll actually go, okay, 1 and 24, 2 and 12, 3 and 8, and 4 and 6. It doesn't really matter how you do it. These are the groups. These are the factors that multiply to 24. Which of these guys multiply to 24 and add to 11? 3 and 8. So we're going to go plus 3 plus 8, right? Because 3 times 8 is 24, and 3 plus 8 is 11. Make sense? We're done. How do you know you did it right? D times D is D squared. D times 8 is 8D. Plus 3D is 11D. And then 3 times 8 is 24. We're done. Make sense? Make sense? Did you guys get that? Does it make sense? Do the next one. What happens if they give you one like this? 9 plus 10t plus t squared. What do you do? Yeah, you just move them. Put them where they belong. You're allowed to shift things around. You guys are math students. You move them around. Fix it. All right, so here we go. Look here. Your eyes are up here again. Again, you need to see it so you're like, oh, I got this. This is easy. Okay, first of all, I don't even like the way that looks. It doesn't feel right. Doesn't look right, so I'm going to fix it. I'm going to make this be t squared plus 10t plus 9. I look at this. First thing I'm going to do, and I'm going to just go, can I pull anything out? No. I'm going to show you one in just a second where you will pull something out. Does that make sense? And I'll show you what to do. It's a quadratic, so I know it's going to look like this. Just set it up, right? So now, what are these first two things going to be? T and T, right? Two T's. And the last one's going to multiply to 9 and add to 10. That's weird. So the factors of 9 are 1 and 9 and 3 and 3. Agreed? Okay, so it's either 1 and 9 or 3 and 3. Which ones multiply to 9 and add to 10? 1 and 9. So plus 1 plus 9. What if I put plus 9 and plus 1? Is there a difference? No. Doesn't matter. Right? I don't even think I care which one. I mean, maybe I would do alphabetical or numerical order, whatever. How many of you got t plus 1 times t plus 9? Does it make sense? This is a simple puzzle. Agreed? I'm going to show you one. Just you're watching. Okay, you're watching here. This is what I'm talking about. This is where I could easily hand this to you, and on your test, I know I hand you questions like this, where I say, okay, I want you to factor this. I just say factor. I don't say blah, 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 and then factor. No, I just say factor. First thing you do is you look and go, can I pull anything out of this? Yes. What can I pull out of each one? I could pull the 2 out. So what you would do is you'd go 2 times t squared plus 10t plus 9. Do you agree that now, you remember the problem we just did? Do you see it's right there? Right? So this is it factored. Are we done? No, because we already know that can this be factored more? Yeah, so it would end up looking, it would be 2 times t plus 1 times t plus 9. Now it's factored. Does that make sense? This is a couple of lessons from now, but that's how you do it. You pull out what you can, and then if you're left with a quadratic, you got to factor the quadratic. Make sense? Okay. Here's a good one. I like this. And listen, here's the deal. The rules don't change just because things look different. The rules stay the same. Okay, so I'm going to see how many of you can do this with the rules being the same, but things looking a little bit different. So what's different about this one? There's a negative in there, right? It's a negative. Nothing changes. Still straight up. First thing you do whenever I say factor, can you pull anything out here? Can I pull something out? No, nothing to pull out. Okay, so is it a quadratic? Yep. What's the first letter is going to be? M&M. M&M, right? M&M. What's the last two numbers going to be? Tell me the thought process. The last two numbers are going to multiply to 21, but add to negative 22. Huh. So either way, we know it multiplies to 21, so what am I going to have to do? Right, the factors of 21. 1 and 21, 3 and 7. That's it. That's all the factors. So now we have to look here and go, okay, what are we going to do here? It multiplies to 21. It multiplies to a positive. Do you see what I'm saying? It multiplies to a positive 21. So that means that what needs to be true here? If it multiplies to a positive but adds to a negative, what would make that true? they would both have to be negatives, right? Does that make sense? And so what two numbers add up to 22 then? 1 and 21. 1 and 21. Now let's make sure of this. Does negative 1 times negative 21 multiply to positive 21? Yes. Does negative 1 plus a negative 21, does that add to negative 22? Yes. We're done. How many of you got that? Nice. Couple of negatives. That's important. The rules don't change just because things are weird, you know. Okay. You guys, I'm going to give you one. No, I'll let you try one of these. It's a good one. Try it. You're watching. First thing we do, can I pull something out? Please don't get used to just skipping that part. You always check. I'm telling you, you're going to, on your test, people miss this all the time because they forget to pull something out. Ugh, kills me. Okay, then it's a quadratic, so we know it's going to look like this. Now listen, you guys are going to get to the point very quickly where you go, okay, you already know this is x and x. You know that, right? I mean, you just know it. X and x, because that's this, right? And then you go, okay, multiplies to 12, adds to negative 8. Ooh, multiplies to when you start saying negatives here, you got to recognize this one. Multiplies to a positive, adds to a negative. If it multiplies to a positive, it's either two positives or it's two negatives, right? And if this guy here is negative, is there any way that me putting a plus here and a plus here is ever going to make a negative? No. No chance. So you already know it's negative and a negative. Now you got to do the factors of 12. 12 is 1, 2, 3, 4, 6, and 12. Rainbow, rainbow, rainbow. What two numbers then add to, we already know that these are all the pairs that multiply to 12, so then which are the two numbers add to 8? 2 and 6. Does that make sense? Right? Simple puzzle, no problem. Everybody got that? Make sense? Okay, I'm going to show you one other kind. This one is the only one that's a little bit, again, nothing changes just because the rule, things look funny. Here we go. I'll give you a good one. Y squared plus 13y minus 48. There you go. Factor that for me, please. All right, I'm going to show you. Here we go. Pencils are down. Your eyes are up here. First thing you look for, can I pull anything out? No. You know it's a quadratic, so it's going to look like this, right? And the first things are y and y. We know this. It's going to multiply to a negative 48. Oh, man, if it multiplies to a negative 48, what is true about the two numbers that are going to go in here? One's a positive and one's a negative. Do you agree? One's positive, one's negative. Okay. So we have to factor 48. There's a lot of them. 1, 2, 3. Did y'all get 3? 48, 24, 16, 4 and 12, and 6 and 8. Right? Got them? All right. They all, oops, that was horrible. 2 and 24, 3 and 16, 4 and 12, 6 and 8. Each one of those pairs multiply to 48. But now we have to look. We know that this thing is going to multiply to negative 48, but the two of them add together to make 13. Remember, one's going to be a positive, one's going to be a negative. Is there any chance that it's 1 and 48? If you combine those two, is that anywhere near 13? No. Is there any way it's 2 and 24? If I combine 2 and 24, is that anywhere near 13? No. What about 3 and 16? If I combine them, if one was positive and one was negative, does 3 and 16 work? Yes. Now here's the deal. This is the kisser. Which one's the positive and which one's the negative? Remember, when you add them together, it makes a positive 13. So what am I going to need to do here? The bigger number is 16 and the smaller number is 3, because when I add 16 and a negative 3, what do I get? My positive 13. Does that make sense? So all you have to, when you're done, look at this and go, does 16 times negative 3 multiply to negative 48? Yes. Does 16 minus 3 equal 13? Yes. I'm done. Did anybody get that? Okay. Does it make sense? Remember, when you have this guy out here negative, then all of a sudden you're dealing with a positive and a negative. You've got to put them together and figure it out. One last thing, one last topic I'm going to give you. Well, we'll do this right here. We're going to leave this. Here's the question. What happens if I gave you this if I gave you this exact same thing, except I made it into an equation equals 0. And I want you to solve it. Line down the equal sign, right? Line down the equal sign. What do I need to do here? You factor this. It's a quadratic, you factor it. It ended up being, what was it again? It was y plus 16 times y minus 3 equals 0. So now look here, people. Remember, if either one of these babies, if him or him equal 0, then we know that that'll make it be 0, right? Well, look, this happens real quick. What would this y need to be to make that be 0? Negative 16. What would this y need to be to make it be 0? Do you see what I'm saying? If in the end, if you end up with this, if you end up with r plus 4 times r minus 6 equals 0. If you end up with that after you factored it, what's the solution? What is the solution, people? It's r equals, what would make this be 0? Negative 4. What would make this be 0? How hard is that? Let me give you another one to make sure you get this. X minus 2.8 times x plus 3/5 equals 0. What is the solution? Negative 2.8. So it would be a positive 2.8. Agreed? So x equals 2.8 or a negative 3/5. You see what I'm saying? Whatever's going to make either this be 0 or this be 0, anything times 0 is 0, right? I'll give you one to do. I'll let you do one. Knock it off. Okay, remember this one? M squared plus 20, minus 22m plus 21 equals 0. If you have your work, you can already do it. I mean, whatever, or you can do it again. I don't care. I want you to solve that equation. Suddenly, I don't tell you to factor. I tell you to solve. But you have to solve it by factoring. Okay, so here we go. You're watching, right? In the end, you already know how to do this. Line down the equal sign. Shh. Line down the equal sign. Once we factored this right, it comes out to m minus 21 and m minus 1 equals 0. Agreed? We've done this. Negative 21 times negative 1 does equal 21, and negative 21 plus a negative 1 does equal negative 22. So we're good here. So then really quick, I mean, can you just do this and without even doing any math? What is the solution? M equals, what makes this 0? 21. What makes this 0? 1. I would switch them around, 1 and 21, but there they are. That's how you'd solve it. Does that make sense? One last thing. What happens if they do this? What if I gave you that same exact question and I said m squared minus 20, was it 2? Minus 22m equals, and then I have negative 21. The only way this works, the only way it's a quadratic equation, the only way it works is if what? It looks like this. If it says x squared plus bx plus c equals 0. So what's the difference between this one and this one? What's the difference? There's no 0. So fix it. What do? You make it work. I can simply add 21, and you know what that gives us at this point? Now we're suddenly at m squared minus 22m plus 21 equals 0, and now we're where we belong. Does that make sense? You force it to equal 0. You clear everything out. And as long as this is a quadratic, then you can do it. Stop putting things away. Your homework. I'm giving you the odd problems. Why have I given you the odd problems? I'm allowing, no, they're not easier. I'm allowing you to, when you're done, to go to the back of the book and make sure you got them all right. If you didn't get it right, what should you do? How stupid would it be for you to go in the back of the book and go, oh man, I missed half. And you go, that's too bad. And then that's it. You come to class the next day. What would be the point of that? All you learned was that what? That you don't know how to do half of them. That's all you learned. So you go back and go, oh, what did I do wrong here? Oh, I see. You've got to learn something from your mistakes. Otherwise, it's a total waste of your time. So it's possible that you will all waste your time tonight if you don't go back and figure out what you did wrong on the ones you missed. Make sense? Okay.